problem 29. Okay. This one feels cruel to me because there's some conditions in here which, like, the whole structure of this diagram is really weirdly defined. Okay, so I'll just read the problem first. Congruent non-overlapping circles A, B, C, and D are positioned in a plane such that A, B, and C are mutually tangent to each other, and circle D is tangent to circle C. Triangle EFG circumscribes the four circles as shown. If the radius of each circle is 1 meter, then the length of side FG can be expressed in simplest radical form as A plus B root C meters, where A, B, and C are integers. What is the value of A plus B plus C? So I take slight issue with this problem statement because you're supposed to be able to construct the diagram, like, even without like seeing an example of it. Like, I should be able to make this diagram, even if they didn't give, I should just be able to make it based on the text. And it's oftentimes true that you can make it with like slightly unclear. It's fine if the problem statement is slightly unclear, so there's like 2 or 3 possible ways to construct the diagram, where it's just like, is this line inside or outside, and it can make substantial changes. But you should be able to narrow it down to like 3 or 4 at most cases. But here, there's a complete degree of freedom. There's like an entire degree of freedom, which is just not stated at all. And it's the fact that B, C, and D are collinear. Which just feels really cruel that you have to deduce this from the diagram. But yeah, you have that B, C, D, and are collinear because they share a tangent line and they all have the same radius. And then this little triangle here is pretty well defined. And so the next thing to notice is that angle FEG equals 90. It looks kind of like a right triangle. And this does in fact end up being true because AB is perpendicular to EG. And EF is perpendicular to the perpendicular bisector of AB. So AB is perpendicular to EG, and EF is perpendicular to AB, it's perpendicular bisector. And this makes sense because EF is parallel to AB, and then AB's perpendicular bisector is equal to CD. So EF is perpendicular to CD, but we also have that CD is perpendicular to AB. There's probably some simpler way to state it, but it ends up being true that angle FEG is 90 degrees. And also, in fact, it actually doesn't really matter. So I'm going to shrink that. You know the slope of EF. Because angle EFG is equal to angle ABC. Angle EFG equals angle ABC because AB is parallel to EF and BC is perpendicular to FG. So this is angle 60. Yeah, let's just go. Yeah, when we prove that that angle is 90 degrees, and then that means that this is 30. And so we actually have that this entire triangle that is like circumscribed around these 4 circles is a 30, 60, 90 triangle. And this makes our life a lot easier because instead of finding FG, we can find EF. Finding EF is the easiest side length to find of the 3 because over here, we get 15-degree angles, which are really bad to deal with. So over here on EF, this length over here has side length 3 because there's 3 radiuses. That's 1. This is a bisector, so that's 30. So we have another 30, 60, 90 triangle here. So this is root 3. So EF equals 3 plus root 3, which means that FG, so this is EFG is a 30, 60, 90 triangle. This is double EF. So this is 6 plus 2 root 3, and then we add them up, and A plus B plus C is equal to 11.